Welcome to this week's IGC Events webinar focused on geothermal, which is presented by Think Geoenergy and Enerchange. My name is Jochen Schneider. I am the Director of Enerchange. I'm glad to welcome today also Elif Kaymakci from the EnBW Energie Baden-Württemberg AG and you everywhere in the world to another Friday Energy Talk. We are really impressed by the high interest with more than 300 registrations. It seems that the presentation, Lithium for Batteries from Geothermal Waters in Germany, the joint project Unlimited, hits a hot topic. In the Upper Rhine Valley, actually, there are 4 projects for lithium extraction underway. One is on the French side, Électricité de Strasbourg, and they reported just recently that they managed to extract lithium from the geothermal brine. And there is this project here, the Unlimited project. Third project is the brine mine project we will hear in German Blickpunkt presentation. And then the fourth project is by Vulcan Energy. However, all the projects are different and not connected. As we have so many registrations today, and I expect also as many participants, we have to limit the questions in the discussion later after this presentation. So every person will have only the chance for asking one question, as the webinar will finish at 3 p.m. But let us start now with a short introduction. Elif is a chemical engineer experienced in project management across multiple conventional and renewable energy projects for around 10 years. She earned her master's degree in renewable energy and environmental management at Europa University, Flensburg in Germany. During her master's degree course, she joined the geothermal energy R&D team at EnBW, wrote her master thesis on the optimization of the Bruchsal geothermal power plant, and has worked as a project manager in geothermal energy projects at EnBW R&D since November 2017. Currently, she is leading the research project Unlimited, in which lithium extraction from geothermal brine is to be realized in Bruchsal. Her area of specialization is power plant engineering, chemical engineering, thermodynamics, and economics. Elif, the floor is yours.
Thank you very much, Johan, for this nice presentation. So I would like to welcome everyone who is taking the time and participating in this presentation today. My name is Elif Kaymakci. I'm currently leading the project Unlimited at EnBW, in which we aim to produce lithium as co-product at the geothermal power plant Bruchsal. I will give insight into the Unlimited project in this presentation. Before moving on to the project information, we will be first looking at the lithium metal, its importance, and the geothermal lithium activities worldwide. I want to begin with the necessity of lithium in energy revolution. Lithium is seen as a keystone in the transition to 100% renewable energy. In recent years, as we all know, transition to clean energy has become indispensable in combating increasing environmental pollution and climate change. And all clean energy technologies are indeed mineral intensive, and lithium is one of these minerals used in clean energy technologies. The uses of lithium are diverse. Rechargeable batteries hold the biggest share with 54% of the total lithium demand. Most of today's electric vehicles use some form of lithium-ion battery because lithium-ion is the most prolific battery technology due to its high energy density and storage capacity. Lithium is also used in ceramics, greases, polymer, air treatment, and other industries. So the demand is high, and it seems like the strong growth in demand to continue in the future. Considering these facts, and also the need for sustainable production, sustainable lithium production, energy, automotive, and technology companies are getting together to foster an energy revolution with lithium batteries. So lithium is important in the energy transition, but what about its future supply? Will it be enough for the entire world? Projections show that the global demand for electric vehicles will grow exponentially in the coming decades. And on the left graph you see here a very recent projection by Canaccord. They estimate that the lithium demand in terms of lithium carbonate equivalent will be more than 800,000 tons by 2025, and it will be around 2 million tons by 2028. When examining the global lithium production, the graph on the right shows another estimation on the lithium supply by country and type until 2025. Lithium is mainly sourced from either spodumene or brine. Australia is home to most of the spodumene mines, while brine production is concentrated in South America, mainly in Chile and Argentina. Also, NS Energy profiled the top 5 world largest lithium market players based on their market capitalization and revenue. And in this list, there is Albemarle Mineral Resources Limited, Tianqi Ganfeng Lithium, which has plants in China, Australia, Argentina, in Mexico, and Tianqi Lithium has also plants in China, Chile, and Australia, and also SQM, which has plants in Chile. So the lithium production from geothermal resources is expected to be in the future supply chain, as there are many geothermal lithium activities ongoing around the world, as shown on the map here. The Upper Rhine Valley, alongside the German-French border, the Salton Sea in California, and Cornwall in the UK are known as the areas with the highest lithium content in geothermal brines. Therefore, there is a lot happening on geothermal lithium in these regions. In the US, several companies received funding for geothermal lithium demonstration projects. And in the UK, in Cornwall, Cornish Lithium has 2 main sites which are under development. And our project, which is going to be realized in Germany at the Bruchsal geothermal power plant, which is in the Upper Rhine Valley in Germany. And I will give details about this project in the next slides. Also, in Germany, there is Vulcan Energy who is investing in lithium geothermal lithium. But about the pilot site, as far as we know, we don't have new information about the pilot site of this project. And France is also being very active in geothermal lithium, as also Johan mentioned in the beginning of the presentation. Just a week ago, Eramet Group and ES Geothermy has confirmed successful lithium extraction from geothermal brine at the Rittershofen geothermal power plant. Also in New Zealand, Turkey, and Kenya, there are several projects planned regarding lithium extraction from geothermal water. So how is the lithium content actually in Germany and also at the pilot site of the project Unlimited? Here you see a chart with lithium concentrations in geothermal brines in comparison with the other sources. In the Upper Rhine Valley, the concentration changes between 100 to 200 milligrams per liter, and it is around 240 milligrams per liter in the North German Basin. The brine in the US Salton Sea has concentrations of between 100 to 400 milligrams per liter, and the brine in the UK in Cornwall has around 260 milligrams per liter. Comparing these lithium concentrations in geothermal brines with the ones in salt lakes, which are in Chile, Argentina, Bolivia, and China, these concentrations are remarkable, which are existing in geothermal brines. And according to our first estimates, the annual production in Bruchsal for lithium is going to be around 808 tons of lithium hydroxide monohydrate and 712 tons of lithium carbonate. And on the right side, you see the map of Germany, where North German Basin and Upper Rhine Valley is located. and also you see the site of the pilot site of our project Unlimited, Bruchsal. It's located at the edge of the Upper Rhine Valley. So let's look at the project Unlimited in more details now. In this project, EnBW, together with partners, is going to test the co-production of lithium at the geothermal power plant in Bruchsal. We first would like to give our special thanks to the German Federal Ministry of Economic Affairs and Energy that is funding our project with 2,007 million euros. EnB is the consortium leader of the project, and its partners are Karlsruhe Institute of Technology, BESTEC, Hydrosion, and the University of Göttingen. Actually, there has been misinformation on the media recently regarding the partners of the project. Apart from these partners, we are not in cooperation with any other parties. And one of our focus points in this project is to carry out a resource analysis for the Upper Rhine Valley and North German Basin to determine the size of the lithium deposits, the possible recovery rate, and the sustainability of the management. And another focus point is the identification of suitable adsorbents in laboratory tests, and after confirming the laboratory tests and considering the results of the laboratory tests, a pilot plant will be designed and suitable adsorbents will be tested in Bruchsal. I'd like to give a quick overview to the project pilot site Bruchsal geothermal power plant. Here you see the history of the plant. EnBW got involved in the project in 2005. And has been operating the geothermal power and heat plant together with the Bruchsal municipality since 2010. At the beginning, the focus was actually on electricity generation. However, in order to make geothermal energy more economical, EnBW has decided to utilize the heat as well, and it has also been supplying heat to the customers in the vicinity of the power plant since 2019 for the police station, which is near to Bruchsal. And in this Bruchsal geothermal power plant, various research projects have been conducted since 2009. The focus of the investigations in those projects was on the creation of geological and numerical site model, as well as the identification and minimization of the risks, technical and economical risks, and also optimization of the plant operation. And lately we are conducting this R&D, research and development project Unlimited, to extract lithium from geothermal waters in this geothermal power plant. So the design data of Bruchsal, you see a flow chart of the thermal water circuit, power production and district heating circuit. Bruchsal uses a hydrothermal system. This means that a natural hot water source in a relatively low depth of 2,000 to 2,500 meters is operated in a doublet system. We are using a downhole pump to produce geothermal water with a wellhead temperature of 123 degrees Celsius, and we are re-injecting the geothermal water back into the injection well with a temperature of 60 degrees Celsius. And the electrical output of the power plant is 550 kilowatt. In Bruchsal, we are using a binary cycle Kalina technology. The difference between the regular organic Rankine cycle system and the Kalina cycle system is the choice of the working fluid, which is ammonia water mixture for Kalina cycle technologies. And for the district heating plant, the thermal power output is 1.2 megawatt and with a partial flow rate of 6.25 liters per second. So now we will have a look at the lithium extraction process from geothermal waters. You see an illustration of the process. After the lithium enriched Bruchsal geothermal water has been used for generating electricity and heat, it is fed into the direct lithium extraction plant. First, the geothermal water is pre-treated, and then sent to the direct lithium extraction stage here. After the lithium is extracted from the geothermal water is sent back, pumped back into the underground, as you see here. And there are different extraction technologies available for lithium extraction. And in our project, we are using absorption technology because our laboratory scale studies showed very good performance on the absorption capacity. Also, you see a comparison table here between these different technologies in terms of their feasibility, compatibility, size of the plant, economic and environmental aspects, technical maturity, and market availability. This comparison is made based on a detailed literature study. So, as you also can see on the table, the application of an absorption process stands out from the rest because of small space, relatively low investment costs, and also compatibility with the environment. So after the lithium extraction plant here, the lithium is extracted from the geothermal water, and lithium enriched solution, analyzed solution, is sent to the lithium production plant. In the lithium production plant, first refining begins, in which the lithium enriched solution is further concentrated and fed to the final process for conversion. And finally, at the end, a highly pure lithium as lithium carbonate or lithium hydroxide monohydrate is produced, which can be used in the production of batteries. So what is actually this absorption technology? It is consisting of two steps. First, lithium is captured and then it is released again from the adsorbent. In the adsorption process, the geothermal water comes into contact with the lithium selective adsorbent, which is made of manganese oxide in an adsorption column. You see the adsorption columns here, which are filled with the adsorbents. And here you see the process and illustrated on an illustrated picture. The lithium ions in the geothermal water are absorbed on the adsorbent. Here on this picture, the big black particles are representing the manganese oxide adsorbent particles, and the yellow particles are representing the lithium ions, and the other colorful particles, red, green, and the other colors are representing the other components in the geothermal water. And yes, the specially treated adsorbent selectively adsorbs, as you see here, and binds the lithium ions from the geothermal water. However, other components of the geothermal water flow over without being captured on the adsorbent. This process is very fast, and in the end of the process, we are having lithium-enriched adsorbent plus lithium-depleted brine. Lithium-depleted brine is sent back to the underground, and we are having lithium-enriched adsorbent, as you see on this picture here better clearly, and lithium ions are absorbed on the adsorbent. And in the second step, desorption begins. Instead of geothermal water, this time adsorption column is now filled with a desorption solution. This desorption solution, here you can see it, desorbs the lithium from the adsorbent. And actually, in other words, lithium ions are released from the adsorbent and transported into the solution. Now, after this desorption is completed, we have lithium-depleted adsorbent and lithium-enriched solution. So you can see the better version of this desorption, lithium ions, how the lithium ions are actually released from the adsorbent and with the addition of the desorption solution. And by releasing the lithium ions from the adsorbent, we are actually regenerating the adsorbent, which can be used again starting from the beginning of this adsorption process. So to recap the project status, I would like to summarize what we have done actually and what are our next steps. We have finalized our preliminary laboratory tests, and manganese oxide adsorbents showed very good performance. Their absorption capacity was high, and they were very selective in terms of capturing lithium. And besides, the absorption of the competing ions was very low. They also showed high stability. It was possible to complete several cycles before it was depleted. Kinetics of the absorption was very fast, and we have also seen a positive correlation between the temperature and absorption capacity, kinetics, and the selectivity of the absorbent. We continue our experiments with different absorbents in order to find the most suitable one for our process. And beside that, we are now conducting our tracer tests, and design of the power plant and the monitoring system are being developed. And as next steps, we will be constructing the pilot plant, which is going to be end of 2021, and also the beginning of the 2022. And then we will focus on optimizing the process and also assessing the techno-economic feasibility. So to sum up, fundamental investigations need to be conducted to realize industrial lithium production from deep geothermal waters in Germany. Once these investigations are completed and successful operations are confirmed, it would be possible to contribute in the supply chain revolution for lithium compounds in Germany. And in our project Unlimited, we are focusing on the origin of lithium in order to estimate the size and sustainability of the source. This is very important for being able to use this technology in an industrial scale. We need to know how sustainable it is, and would it be sustainable for the future, or would it be enough to produce lithium from geothermal water? So this is a very, very critical investigation that needs to be completed. And also economic viability and compatibility of the extraction method. This is also very important. It needs to be compatible with the geothermal plants. And also social acceptance, as also in other projects, is very important. It's also important in lithium extraction projects. So these focus points, we think, would be very helpful to understand whether the lithium production from geothermal waters is feasible or not. And EnBW, based on the results of this project, also having long-term goals for this lithium extraction, because lithium concentrations in the Upper Rhine Valley and North German Basin are remarkable. And based on the first estimations, the amount of lithium that can be extracted in Bruchsal annually is alone about 20,000 batteries. So that's why EnBW is having long-term plans in extracting lithium from geothermal waters. Once a successful lithium extraction at the Bruchsal geothermal power plant is confirmed, EnBW will take this technology further and scale up the existing plants with its partners. And in the long term, the expansion of the further geothermal projects with co-production of lithium are also planned to support EnBW's decarbonization goals and also to contribute in the energy transition to 100% renewable energy. So I would like to thank you very much to all of you for paying attention and attending this presentation. Thank you.
Thank you very much, Elif, for this very nice, interesting presentation. We have already many questions, and I want to start immediately. Are in place any specific tools from EU or local authorities promoting the development of lithium extraction through geothermal exploitation, i.e. funding schemes, tax impacts, feed-in tariffs?
Yes, it's actually a very good point. European Union, I think, is preparing a funding scheme for lithium extraction projects. We are also following those funding programs. But actually, nothing specific yet has been published.
Okay, thanks. How much does the brine cools in the absorption process?
Yes. There is no cooling in the absorption process. There is just absorption and desorption. The temperature is 60 degrees, and actually we haven't. I mean, how much would be the temperature decrease? Of course, it can there can be some temperature effects, but we will see it in the pilot plant. We have only performed laboratory experiments, and the temperature was not changing that much.
Thanks. What is the source of the lithium? Are the geothermal fluids circulating through a lithium-rich sediment or a pegmatite? Where does the lithium come from?
Yeah, that's actually what we want to know in our project in order to find the source of the lithium deposits, and this is part of our project, and we are working on that, and we are analyzing lithium isotopes, and that's why we are making also tracer tests. We need to find out if it is coming from the rocks or it's already in the liquid, but it's definitely a mixture of both, because there is like fluid rock interactions. But in order to reply this question better, we need to have first some data from our investigations.
The next question is in the same direction. What is the lithium concentration in the brine? Does the concentration remain steady, i.e. does the lithium concentration diminish due to depletion of the source or diluting with injection water?
Yes, that is also the question, the fundamental question that needs to be replied. We are also looking into this question, and we need to know. I mean, the concentration is known already. We know it's changing between 100 to 200 in the Upper Rhine Valley, and but we need to know how sustainable is the concentration. Are we going to have this concentration for 5 years more in the future? Or that's why we are conducting these tests for sustainability management and also the resource analysis. And later on in our project, we will be able to reply those questions with some real data.
But in the actual process or in the actual operation of the plant, it's stable.
Yes, right. It is stable. I mean, we have measured the lithium content several years ago. It was same, and right now we have also done some lithium concentration analysis recently in 2020, and it was showing the same concentrations. So it is right now stable, but we haven't produced lithium from geothermal brines in Bruchsal power plant. So after the first tests and several years of operation, this can be replied, but we, of course, in the research project, we will be able to reply these questions after our tests of the resource analysis.
Thanks. Here is an interesting question. When the manganese oxide adsorbs lithium, it releases hydrogen, which influences the pH of the geothermal brine. Does that have an effect on the injection side of the reservoir when more acidic water is injected?
Yes, this is, you're right. This is an interesting question, and we are already aware of that. And we are thinking to inject some buffer solutions to keep the pH stable and not go acidic before the injection of the brine. Yes, this is very important. And that's true. Hydrogen is released in the solution, and it's decreasing the pH. Definitely, it's making the environment acidic. So we are definitely thinking to balance this with a buffer solution.
Okay, thanks. Yeah, from different media, there was the impression that Vulcan Energy is partner of the EnBW in lithium project. Isn't this info correct?
No, this is not correct. We are not in cooperation with Vulcan Energy. I actually meant, yes, I wanted to, or we wanted to mention this in this presentation because it was on the media recently that we are in cooperation with Vulcan Energy, but it's not true. I have listed our partners in my presentation, and other than these partners, we are not in cooperation with other parties.
Perhaps you can show the slide with the partners again.
Yeah, sure.
From which aquifers can lithium be extracted in the North German Basin?
Yes, we have some sites where we can take some geothermal brine samples, but this is not yet decided. We are still searching the most proper sites, and then we will collect samples and analyze them in our laboratory.
Okay, what flow rate can currently be reliably processed by the system? Is lithium extraction at flow rates of 60 liters per second at all technically and logistically feasible as currently claimed by competitors?
Yeah, actually, this really depends on the concentration as well. You need to look at the flow rate and also the concentration of lithium in the geothermal brine. As I showed in the design data of Bruchsal, we are having 30 liters per second, and we made our calculations based on this 30 liters per second and between 100 to 200 milligrams per liter lithium concentration. So it's also possible with higher flow rates and low concentrations to have a sustainable process or enough lithium to produce for the market.
Okay, thanks. The next question is, thanks for the nice presentation. What would be the additional CAPEX and OPEX, so on top of the wells and normal geothermal facilities required for full commercial operation estimation?
Yeah, this full CAPEX and OPEX, as I also mentioned in my presentation, is part of Unlimited project. We are working to develop a model, techno-economic model, to find which parameters are important in CAPEX and OPEX. At the moment, we don't have the results for this economic analysis, but this will be one of the outcomes of this project.
Thanks. What is your timeline for the development of the adsorbent? How do you deal with the CO2 and the heavy metals of the Upper Rhine Valley brines?
How do we deal with the CO2? Yes, CO2 is also an important topic in the Bruchsal power plant, and we are already having a separate project for CO2 injection in the Bruchsal power plant. A colleague of mine is doing her PhD on CO2 reinjection. Yeah, I mean, right now we haven't focused on the CO2 part in the adsorption in the lithium extraction technology, but we are considering the CO2 content of the geothermal brine. If yeah, I mean, if they want to get more information about CO2, they can contact us and learn more about our CO2 projects.
The next question, thanks for the presentation. After reinjection of lithium pure brine into the ground, are you expecting that the brine produced would tend to decrease in lithium concentration?
Yes, this question, actually, we don't know this and we cannot reply this right now. But this is what we are also considering. We need to see if it's sustainable, if it is if the resource is there and it's reproducing itself after we are exploiting it. But yeah, this is definitely something that we are considering, and we will be considering in our project. That's why we are going to monitor the operation to see if anything changes while we are producing, while we are extracting lithium. The monitoring system, therefore, is very important in this project. That's why we included that.
But this is also tested by the tracer test before. Normally it should say anything about the duration, how long it needs that the water comes to the production well again.
Yes, exactly. This will be also an outcome of the tracer tests. After the tracer tests, we will be able to reply that. You're right.
Okay, here just a comment. Excellent talk. Thank you very much. What is the lower limit of lithium concentration that can be expected to be viable economically?
Yeah, again, it really depends on the flow rate as well. It's not only a parameter itself, which I can say, okay, this concentration would be definitely enough to produce lithium. But there are, for example, I mentioned that there are also projects planned in Turkey. And as far as we know, the lithium concentration in Turkey changes between 9 to 40 milligram per liter. But it really depends on the flow rate, because there are some geothermal power plants in Turkey which have really high flow rates. Then you can really compensate between the flow rate and concentration and still produce enough amount of lithium, which would be economically viable.
Comparing to the Salton Sea project, which has so far solely showed lithium extraction from a geothermal brine with a very high reservoir temperature of 300 degrees Celsius and higher overall lithium content, is lithium extraction really economically profitable in the near future in the Upper Rhine Graben, or will it be a subsidized market?
Yeah, definitely. There are still unknown questions or unknown parameters regarding this process, and before to make it economically viable or to realize this project in an industrial scale, we need to first reply these questions. But there are successful projects, demonstration projects, and there are also studies on the economic part and environmental part. So we believe that with the enough concentration and flow rate, this process can be viable. But definitely we need to also test the compatibility of the process, because there are also projects which have failed in the world. So I think before we can say everyone who is dealing with these projects, lithium extraction projects, before we can say something, we need to really see the demonstration of and the data from the demonstration sites in the long term, or at least for some time, not maybe long term, but just for some time. But definitely these concentrations are remarkable in the Upper Rhine Valley, in the Salton Sea and Cornwall. So they need to be looked into and analyzed.
Hi, Elif. What would be the feasible limits of lithium for this kind of investment? According to the European map, I saw minimum 100 ppm. I think we already answered this question before, that it's also depending on the flow rate, and in general you cannot say, as also other projects with very low concentrations are trying to.
Yeah, I mean, you know, as I said, 40 ppm, this is what we know from one site, one geothermal reservoir, 40 milligram per liter. And with high flow rates of geothermal water, this can be still feasible. So we cannot say it has to be minimum 100 milligram per liter. Or, yeah, I mean, if the flow rate is very high, it can still be very, economically viable. Yeah, this needs to be investigated, of course.
Yes, it's in the end an important point here.
Yeah.
The next question: how high is the lithium absorption capacity?
Yeah, good question. Absorption capacity is definitely changing between 70 to 90%, but there are processes who are achieving or which achieved absorption capacities more than 90%. So it's actually promising, this absorption capacity in this technology.
What are the actual production costs and what factors could improve these?
Yeah, unfortunately, lithium production costs, we cannot reply right now. This is the main question that we need to investigate and find out in our lithium project. So hopefully we will be able to publish something on this later, after the first estimates. But right now, the lithium production cost, we need to look into so many parameters in capital costs, operational costs. But right now, first we are focusing on the pilot plant, the technical part. We need to first see and try it in the real operation, and then comes the economical part.
What is the temperature of the geothermal brine?
In our power plant, it is the wellhead temperature is 123 degrees.
I represent a group of Israeli scientists. We have developed selective adsorption material for lithium extraction. Are you ready to test it?
Okay, they can contact us if they want to.
Okay. Is adsorption a cost-competitive DLE process?
Yes, this needs to be found out, as I think we also replied this question. In order for it to be cost competitive, first there are several investigations need to be done. So we are focusing on them. But it can be. I mean, the process is promising. Our first estimations, first calculations are showing that, yes, especially when it is combined with geothermal power and heat production. Not only lithium extraction, but if it is produced as a co-product in geothermal plants, because so far it hasn't been extracted from geothermal waters, and it's just pumped back. Especially in those places where the lithium concentration is very high in the Salton Sea, Germany, Upper Rhine Valley, and also in the UK, Cornwall. So if I just imagine that it had been extracted since years, so yeah, we just need to look into the economic analysis and make the process economically viable. But the process, as I said, ion exchange process and adsorption process are promising processes for lithium extraction.
Okay, thanks. Which architect engineering company is planning and erecting your lithium process? Do you have a partner who delivers the plant on a turnkey basis?
No, we don't have.
Okay. What is the expected ideal temperature of the brine for the extraction process?
Yeah, as I said, the higher temperatures showed better performance. First, in the past, we have tried the lithium extraction in the room temperature, but later on we tried or we repeated our tests with the higher temperatures of thermal water at 60 degrees, around 60 degrees, and they are showing better performance. So that means it should be around 60 degrees, at least for Bruchsal geothermal power plant, because we are reinjecting the geothermal brine at 60 degrees, and it will enter the lithium extraction plant with 60 degrees. So this is already showing good performance. I think this would be ideal for a Bruchsal power plant.
Thanks, Elif. Thank you for the up-to-date insight, the Unlimited project. My question, do you encounter any major problems with scaling deposition of carbonatic or other unwanted mineral matter during the extraction process? If yes, how do you tackle this?
Yeah, as I said, we are right now designing our pilot plant, and we haven't tested yet our pilot plant or lithium extraction on in the operation. So I think we will be able to reply these questions also after the pilot plant. But scalings, because of the lithium extraction. Yeah, right now we don't have any estimations on that.
Is there a mineral association that can be a marker for a relevant presence of lithium in geothermal brine?
Yeah, from the geothermal waters, we know so far is the lithium, but the other minerals are existing in the geothermal water in trace amount. So we are focusing on the lithium right now.
Okay. Are you planning further plans?
Yeah, I mean, once a successful operation of lithium extraction is confirmed, yes, we have future plans on lithium extraction. First of all, EnBW is also planning further projects in geothermal energy. So when we have geothermal energy and also a successful plant for lithium extraction, we would like to combine these two projects which are providing clean energy, of course.
Do you expect scaling effects in the reinjection well due to lithium extraction and possible temperature lowering?
Yeah, we are actually not expecting to decrease the temperature of the geothermal brine, but of course, if the temperature goes below 60 degrees, yes, corrosion can occur, especially in terms of silica corrosion, because so far we have managed that by keeping the temperature around 60 degrees, but it would not be good if the temperature goes below to 60 degrees. But we are planning to maintain this this temperature as it is.
Okay, thanks. Thank you, Elif, and my compliments to the well-structured presentation. Will the power generation with the Kalina process still be continued if the lithium will be extracted in parallel with 500 kilowatts, or is only one process possible?
Yeah, I mean, I think I also have applied this in the presentations, the compatibility. This is very important. Of course, we would like to keep the electricity production in our plant. And we would like to, as I said, we would like to produce lithium as a co-product beside power and heat generation. And if it's not compatible with the operation, yeah, we will see in the end of this project or during this project. But compatibility is very important for lithium extraction from geothermal waters, because there are so many geothermal power plants in the world. And if lithium extraction is not possible to be produced in parallel to electricity generation, I'm not sure if it would be economically viable. But depends, but still depends on the flow rate and the concentration, I would say.
Do volcanically active regions such as Iceland, Kenya, the Philippines, etc., tend to have a higher or lower lithium concentration than less active regions like Germany?
Actually, yeah, this is, I have been searching this a lot, but I couldn't find I couldn't find the concentrations in Iceland, the lithium concentrations. But Kenya, there are also some projects planned in Kenya, and in one of the reports which was issued in the literature was saying that the lithium concentration in Kenya is around 1.5 to 2 milligram per kilogram of lithium in geothermal brine. But I am not sure how are the flow rates. I only know of Kenya, know of lithium concentration in Kenya, but I don't know how is the concentrations in Iceland actually. It's yeah, I was also curious if they are higher, because there are also some projects, I guess, in Iceland. They want to also look into lithium extraction from geothermal. But yeah, their geothermal plants, the type of their geothermal power plants are a bit different. Yeah, it needs to be, yeah, I mean, I don't have any data for Iceland.
I think it's not dependent on the volcanically active region. It's more dependent on the host rock and where the lithium is incorporated in the minerals. Okay. Are there also noble earth elements in the brine?
There are other elements, definitely, but the concentrations are important for us. Lithium is having the highest concentration among the other elements. That's why we wanted to look into this one.
For what technical reasons is the extraction made downstream of the geothermal plant instead of upstream of the geothermal plant?
Yes, then we could affect the temperature maybe, and I don't know, this is a good question actually. We haven't thought of it before.
The extraction process is much more effective on the cold side.
Yes, it is. Yeah, it's definitely much more effective. If it goes higher temperatures, I don't think it's going to be showing a good performance. This is, yeah, that's why definitely we focused on the reinjection part, and also we don't want to affect the geothermal power plant and also heat power plant.
Do you know any positive correlation between lithium concentration and depth or lithology in the Upper Rhine Graben?
No, I don't know of any correlation between those parameters.
Can manganese adsorption be applied in Turkey?
I don't know what kind of technology they are planning to use. I have just seen that they are planning lithium extraction, but nothing is specific. I think nothing is also solid yet. They just have it in their plans. Yeah, but no technology or not a specific, a particular technology is mentioned.
Okay, thanks. What about the physical stability of the adsorber media within the adsorber column? What about blockage within the adsorber bed due to scaling as well as fine particles?
Yeah, I mean, yeah, we can just consider the adsorbent particles creating a problem in the reinjection line. And we are right now investigating in these problems, possible problems, how they can be solved. But of course, yeah, I mean, adsorbents can create some scaling problems, but we cannot say it precisely at the moment. That's why the design of the plant is very important, the particle size and how it should be not affecting the reinjection process. The design is very important in order to avoid this.
Does the manganese adsorbent need to be replaced after being used for some time?
Yes, it is regenerated and it is possible to use it for several hundred cycles. This is also very important in order to understand the economic viability, but still it's going to be depleted anyway because it's not staying the same after some cycles.
Do you know which possible impurities could co-adsorb with lithium and then enter the lithium-rich annulite?
Yeah, there are some competing ions in the lithium extraction, but actually in our laboratory tests we have seen very successful results. There were very low concentration, very low absorptions of competing ions. Yeah, there is magnesium, sodium, and yeah, and some other elements which are competing with lithium.
So, okay, thank you very much, Elif. We managed through many questions. However, there were many more by some people that being very interested. So it was a very interesting discussion. It was a very interesting presentation. And we can skip now your last slide and come to our next presentation. It will be in the next week. It will be about the brine mine project and hear about the silicium silication and the experiences so far. So thank you very much to all the people listening and asking questions, and thank you very much to you for this nice presentation, and we look forward to any results that you hopefully will present again here.
Yeah, I thank you very much for inviting me and for giving me this opportunity to present our project. Thank you very much, Johan.
Thanks. Bye-bye. Have a nice weekend.
You too. Bye-bye.